and we are continuously trying to really disrupt the automotive industry as one part of our business. And why are we doing that? Because we believe, and I mean what you have seen in the last 2 days, basically every industry is disrupted. And every industry is recognizing that and making the corresponding moves. But from our point of view, the automotive industry could do way, way more. So this is our task with this project. So I'm going to talk about Adrien and myself, we're going to talk about the brain, and we're going to talk about cars. Because we are really car guys. We also believe in self-driving cars, like the Google project. Google X Labs are one of our partners, like the NASA is, like the MIT is. But we also believe in autonomous driving, but we also still believe in manual driving. And we have done a couple of crazy things in the past in order to disrupt the automotive industry. Like, for example, as you know, our brain is not anymore more used to deal with asymmetry. Any kind of asymmetry somehow is weird, and you might have realized that every car is basically in perfect harmony, in perfect symmetric harmony. So what we did is we built a completely asymmetric car. The other thing which we did, and some of you might know this project, this is a car made out of fabric. Certainly with a crash reliable structure underneath. But this is, for example, the way we can hide functions you are not using, like the lights, like the doors. So this fabric is only opening up when we are using certain specific functions. So this is what you see here in the video. And it also gives the car a kind of a human touch, because as you open the door, you suddenly see the car frown and smile. Another disruptive project we did for Volkswagen was we tried to reinvent urban mobility. So this is a three-wheeler. This is for $14,000. Has a very small engine. Needs a little bit more than 3 liters. And as I said, it's a three-wheeler. But none of these projects made it to the market, made it to the customer. So now we are basically entering the age of driverless cars, and specifically also of autonomous driving. And we think this is a great time to hopefully disrupt and speed up the development processes in the automotive industry, because the car is really changing drastically, especially from a consumer point of view. Hopefully the car, hopefully very soon, becomes an adaptive and really contextualized device. It has to be a kind of a real-time sync space. Hopefully we're going to experience soon the zero footprint drive. It has to be a multitasker, an organizer, and by the way, it's going to be the perfect environment to do health kind of measurements within the vehicle. We already heard about the many sensors. And we are working on making the car the zero accident drive, a really zero accident drive. So for example, this is also part of our work. We are working on completely new display technologies like stereoscopic displays. And what you see here already, we are obviously measuring what's going on in the body, biometrics, but we are especially also measuring what's going on in the brain. And the other thing you might see here, and we are sure you've never seen that before, you see an oxygen level going up and down. So this is what we are doing. We are, depending on your state of mind, on your awareness, we adjust the vehicle environment.
And we think that in the future, the way we interact in the car will completely change. For example, we think that in the future we will need, from the driver point of view, to really sense the outside. So really communicate to the driver what is happening outside. And this is critical for the autonomous driving. But it's also really important that the car knows way better about the driver. We have to ensure that when you're driving autonomously and then you change to manual drive, we have to make this transition completely safe. We have to ensure that we understand the driver's emotion and tensions to make this interface really react more reliably. And there are solutions today to really sense the driver, like physiological or behavioral, the way you move, your heart rate. But we observe with researchers that the data is not reliable enough, and we need to access the brain state because it's where everything is starting. And we have a solution, which is to invisibly and passively have a BCI system within the car. So really sensors in the headrest, in the B pillars, so that we can really sense in an invisible way the cognitive state of the driver.
So we are not using these signals to drive the car just by thoughts. We just want to make sure to use the brain-related data in order to basically adjust the vehicle system. So this is what we are doing, and just one key asset, as you can imagine, if you are an autonomous drive, you have a quite normal workload in your brain, and then let's say you're starting to write emails or watching a movie, so the attention workload gets basically up, and this is what we are basically measuring. So, and let's say now you are approaching a highway exit. So you have to leave autonomous drive mode, and we have to make sure that you leave it safely, that you take over into manual drive mode. So we are adapting the vehicle systems in order for you to basically take over manually in a kind of a safe mode. Yeah. We are already out of time, but as Adrien said, key challenge is the electrodes, to make them remote electrodes. You see here the different electrode technologies we are using.
We have transferred what we used to do with gel. We have transferred this capability, this reliability on dry and with low density electrodes. The next step is non-contact, like heart sensors.
Yeah.
All right.